So now here we're going to talk about case number 3 of conjugation, where double bond is in conjugation with free radical. In that particular case, the double bond is in conjugation with free radical, and free radical is in the p orbital. It has to be unhybridized because it is in conjugation. The conjugation are delocalized, so they can't be present in a hybridized orbital. They should be present in pure p orbital. Now, how that could be possible? CH, let's say we have P bond, and from C and free radical H and H. Now, this bond will break and this will break. Now, we are not showing here with the help of like a moving electron, because electron will not move. Because electron will not move, otherwise there will be charge creation, and we don't want charge creation in order to attain the resonating structure over here. So when this charge break, the free radical comes here. When this charge break, the free radical comes here, and it forms a double bond with them. So whenever this charge comes here, there is a free radical, and that free radical is like forming a double bond over here. Now it is forming a double bond over here. So how we can represent the resonance hybrid? Here, it will go here, and this bond will go here, and it will form free radical and double bond over here. Now how resonance structure will look like? CH2 CH2 partial double bond, delta free radical, and delta free radical equals to 1 by 2. Now there is a question over here, we have some examples over here how to draw the resonating structure. So here we want preferably draw the direction of the, or we can say like the bond will break like this and it will form like this. So it will be forming like this, and that how resonant hybrid. Now we won't be drawing the resonance hybrid every time because it have enough practice. We have done that, and delta free radical and delta free radical. Now second question here, it is this type of bond, this will break like this and it will form this. Third, now we have a CH3 free radical, CH2 free radical, which break like this here also, and CH2 free radical, and which break like this over here, and it will form a CH2 free radical over here, which will break like this, and here we have again CH2 free radical, which will break like this. So how resonance hybrid will look like? Again, it will be a CH2 and free radical, delta free radical, and delta free radical, and delta free radical will look like. Now a fourth there is a bond over here, and it will form this. Fifth are 1, R2, and 3, and this bond. So how this will form? It will bring a bond like this, and it will be a free radical, and it will break like this, free radical, and it will break like this, free radical. So that's why it will form a resonating structure. And now in next case, let's see how it forms a resonating structure. Now we have seen the fifth case. Now let's see the sixth case. Now in the sixth case, there is a free radical. The bond will break like this, and the free radical will look like this. And now seventh, how the resonance structure of that. We know there is no conjugation, so there is no resonance. No resonance because there is no conjugation. So that was all about the case number 3, where double bond is in resonance with a free radical. Now when the double bond is in resonance with the double bond, let's talk about the case 4, where double bond is in conjugation with the double bond. Double bond is in conjugation with a double bond. A double bond has to be conjugation with double bond. Now, here again, if double bond is in conjugation with a double bond, C carbon and there is H. C, there is a lone pair and C here we have, and here we have, there is a lone pair over here. Now, what will happen actually? There must be a shifting of electrons, like when let's move in a particular direction. If we move in that direction, then another electron will also move in that direction, and eventually it will form C and C. It will form bond over here, and there will be negative charge, there will be positive charge, it will H, and it will form H and H. Similarly, here it is going like this, so it will form negative charge and it will form positive charge. Right, and how the resonance hybrid will look like? Partial, and delta negative and delta positive. It will look like this, right? So let's draw some of the examples. Let's draw some of the example how they will look like. First, let's take the example of double bond is in conjugation with double bond. Now here double bond is in conjugation with double bond. Now, can the lone pair of oxygen initiate the resonance? No, because when we'll try to initiate the resonance, there will be a 5 bonds in carbon. So in that case, 5 bonds in carbon, which is not possible. So it will resonate in the direction of electronegative element always. So whenever oxygen double bond is participating in the resonance, it will go backwards, right? So the CO negative, H, and here there will be positive charge. So how resonance hybrid will look like? COH, the delta negative over here, delta positive over here, and it will form partial double bond like this. And in the second case, let's say CH2 double bond CH and C double bond OH. It will form, bond will go here, bond will go here, CH2 positive and CH and CO negative, then H. So again, remember the electron will shift on the electronegative side. Electronegative side, element side. It will shift over here, electronegative element side. Third, let's say we have benzaldehyde. Now first this will shift over here. Now initiation of resonance will be from here, positive CO negative, then H, and positive and double bond CO negative, then H. Here also positive double bond CO negative, then H. Then in the bond will go here, and it will form C double bond O H, and 1, 2, 3. So how resonance hybrid will look like? Delta negative, delta positive, delta positive, delta positive. So that's how resonance hybrid will look like. Similar case of nitro, the nitrobenzene. In nitrobenzene also, this initiation due to not the lone pair, the initiation due to negative charge, negative electronegative element of. So it will be double bond N O negative and O. It will positive charge. It will form like this. And here will be positive charge. This bond will go here, this will go here, and it will form double bond. So that's how there will be formation of nitroamine and nitrobenzene, and double bond O and O. So here delta negative, and here also delta positive, and delta positive, and delta positive. That's how it will form. And let's look at the final case when both benzene and forming a resonance, benzene and doing the resonance. So it will do the resonance like this. It will be having two resonating structures.